Hello, this is a geometry video, chapter 3, section 1. We are just starting a new chapter. It is parallel lines and transversals. And before we get started, I just want to give you some definitions, if you will, between parallel and skew. And we're talking about lines specifically right now. And believe it or not, parallel and skew have the same or somewhat the same definition. You'll notice that when I have my bullets here, both parallel and skew share the characteristic that the lines do not intersect. Do not intersect. The difference between parallel lines and skew lines is that parallel lines are coplanar. That means same plane. Skew lines are not coplanar. So the parallel is really easy. Most of you already have seen parallel lines in algebra, not a big deal. You have two lines. In geometry, we denote parallel lines by these two red arrows. And then we have this line that's crossing the parallel lines. But basically we know that JK, line JK, and line LM are parallel. And so they're in the same plane because they're on the same flat surface. So my intent over here with skew lines is to draw two planes. Obviously it's hard to do when you're only on two dimensions. But this line, line L, is on plane A, and line M is on plane B. And so you have these two parallel planes, and because the two planes will never touch, then the two lines that are on the planes will never touch, so they never intersect. But line L and line M are not on the same plane, so they would be considered skew lines. So here we have line L and line M are skew, and of course when we talk about planes, there's not really any such thing as skew planes. You have planes A and B are parallel because they never touch. That's pretty obvious. So what I want to do right now is that this is the easy way of looking at skew lines. There's actually a more complicated way. People always forget these. And so I'm going to ask my volunteers to come up here and help me show you another situation that can happen with skew lines. So here we have a three-dimensional box. And so obviously all of the flat surfaces of this box are planes. And so again, if you had a line, if this was plane A and the bottom of the box was plane B, then line L would just be drawn on plane A and line B would be drawn on plane M and they'd never touch. That's that situation. But also you could have skew lines where, and let's see if my volunteers can get in the way here. Where'd this guy go? Okay, there we go. All right, so I'll hold this side. So we got to get out of the way. So you can come over here, Crystal. Let's rotate a little bit. So again, here's my box. And what you see is that the red piece of yarn here that it's acting as a line is actually on the front plane and on the side plane. Okay? And then we have this other line that's back here. I don't know if you can see here. We can maybe tilt it a little bit. We can see this. That David and I are holding this red line is on the top plane and the back plane. So again, these two red lines will never touch, and they're not on the same plane, and therefore these will also qualify as skew lines. So just wanted to show you another way that you could have skew lines. Thank you, volunteers, for helping us there. So now we're going to go to our example, and hopefully you can see what's happening. It says here, identify each of the following using the wedge of cheese below. Now in your book, this definitely looks like a wedge of cheese. On my board, it just looks like a triangular solid. Okay, but anywho, just be imaginative with me, if you will. So part A says, they want us to identify all the segments that are parallel to JP. And so here's JP. And we have segments that are parallel, which would be LR, because again, on the front plane of the wedge of cheese, you have JP and LR, and they're on the same plane, so they'd be parallel. And also you have KQ, which would be the back side of the wedge of cheese. And again, they're on the same plane, so they would also be parallel. So we're going to name here LR, and these are segments, so we're going to use our segment symbol, and also KQ. So those are the two segments that are parallel to JP. Then in part B it says it wants us to name a segment that is skew to KL. Now remember that skew means they have to be on different planes. So here is KL, and KL is basically the back side, the short back side of the wedge of cheese, but up on top, the top plane. So any plane that's on the bottom would be skew or parallel to the top plane, So skew to KL, any line that's in the bottom plane will be skew to KL. So QR and PQ. QR, PQ are definitely PQ and, did I ever say QR? Oh yes, QR does not work. Actually, sorry, my bad. Let's erase QR. QR does not work, and I will tell you why. QR is on the same plane as KL because it's on the back side. So QR doesn't work, but we do have PQ. That one will work. And then we also have JP. Get my pen back. JP. Now JP is right here. So again, JP is going to be going up this way and KL is going that way. So that's going to be skew. We have one more. Where is my last one, which is PR? PR is one that I wanted earlier. Instead of QR, I wanted PR. So PR is going this direction from the bottom plane, and KL is the top plane, and they're not in the same plane. So there you go. Those are your only 3 segments that are skewed to KL. So hopefully that makes sense. And then a plane parallel to plane PQR. PQR is the bottom plane, so the only plane that's parallel to the bottom plane is the top plane, which is JKL. JKL. All right, so that takes care of this example. So now I have another diagram for you, and you can try identifying some of these segments as well based on this cube that I've drawn for you. All right, then we have a lot of writing. Sorry, this is a short video, but this is the only part where you have a lot of writing to do. But hopefully it'll help you in the long run. My board looks very crowded. I didn't want to have to use more than one page. Your page is a lot longer than mine, so you might be able to fit it a lot better and space it out better. But there's basically 6 different types of angles, and so we want to go through all these different angle pair relationships. So I have a diagram over here to kind of show you what's going on. The first thing we need to talk about is a transversal. A transversal is any line that intersects 2 or more coplanar lines at 2 different points. So here I have line R going like this, and then I have line Q, and of course they're both coplanar on the same plane. They're not parallel, but they are 2 lines. They can be parallel, but they don't have to be. In this case, they're not parallel. And then you have a third line, which we're going to call T for transversal, which intersects both of those lines at 2 different points. So just want you to understand what an actual transversal is. A transversal has to intersect 2 other coplanar lines, but at 2 different points. So if you had a line and a line and a line, then this could not be the transversal because it's crossing the 2 lines at the same point. So that would not be a transversal. So again, a transversal is going to be a line that crosses 2 other lines in 2 different points. So we have our diagram. We have we have Q, we have R, and T for transversal. All right, so based on that, we're going to describe all these different types of angles based on that diagram, okay? So I hope that it makes sense. So the first one up is interior angles. And over there, it's all shaded in green. Interior angles are angles that lie between the lines Q and R. So any angles in this region in between the 2 lines, Q and R, would be considered interior angles. So then I have here the examples. Angle 3, 4, 5, and 6 are all interior angles. Next up is exterior angles, and exterior angles are angles that lie outside or not in between lines Q and R, so outside of Q and R. So that's the blue region. And again, we have angle 1 and 2 and 7 and 8 that are exterior angles. Okay, that's a pretty basic. And then we get to the ones that are more complicated, if you will. And didn't highlight my words, same there. All right. So we have the first up is consecutive interior angles. Consecutive interior angles are angles that lie on the same side of the transversal. Okay, so here's my transversal. So we've got 4 and 5 and 3 and 6. Okay, consecutive interior. They're on the same side of the transversal, but they're also interiors. It says interior angles. So they have to be angles inside the green region, and they have to be on the same side of the transversal. So 4 and 5 are on the same side of T, and they're inside of the two lines, so those will be consecutive interior, and then 3 and 6 would be consecutive interior. And then we have alternate interior, which is kind of like consecutive interior, but the difference is, that's why I highlighted these words here, the difference is that they are on opposite sides of the transversal. So they have to be non-adjacent interior angles that lie on opposite sides of the transversal, non-adjacent. So for example, both angle 4 and 3 are interior angles, so they satisfy the interior part, and both 3 and 4 are on opposite sides of the transversal. But 3 and 4 are adjacent, they're next to each other. So it says also non-adjacent. So for alternate interior, they have to be non-adjacent, interior, and opposite sides of the transversal. So your examples for alternate interior are 3 and 5, and 4 and 6. Okay? And in a similar fashion, you have alternate exterior angles, and alternate exterior angles, again, are non-adjacent. So angle 1 and angle 2 are next to each other, so those would not count. They have to be non-adjacent, they have to be exterior, and they have to be on opposite sides of the transversal. So you would have angle 2 and angle 8, and angle 1 and angle 7. Okay? Hope that makes sense. And then our last ones, which can tend to be the most confusing of all, and hopefully that won't confuse you, but students tend to struggle with the corresponding angles. So corresponding angles lie on the same side of the transversal. So like 1, 4, 5, and 8 are all on the same side of the transversal. 2, 3, 6, and 7 are on the same side of the transversal. But also, they have to be on the same side of lines Q and R. Okay? And that's where it gets kind of tricky. All right? So for example, we have 1 and 5. In other words, the angle 1 is on top of angle Q. It's above, sorry, not angle Q. Angle 1 is above line Q, and angle 5 is above line R. So both angles are above their respective lines, and both angle 1 and angle 5 are on the same side of the transversal, in this case the left. So angle 1 and angle 5 would be an example of corresponding angles. But so would 2 and 6. 2 is above, 6 is above on the right, so 2 and 6 would count. Also, you could have 3 and 7, because angle 3 is below Q, 7 is below R, and both 3 and 7 are on the right of transversal T. Also, 4 and 8, again, 4 is below, 8 is below, and both angles are on the left of the transversal T. So here I have 4 different examples of how you can get corresponding angles. So in our next example, we're going to be classifying this stuff. All right, so it says, refer to the figure below, classify the relationship between each pair of angles as alternate interior, alternate exterior, corresponding, or consecutive interior angles. So first up is angle 1 and angle 5. So we see that angle 1 and angle 5 are exterior angles. They're on the outside of the two lines. This would be the interior. This would be exterior, this would be exterior. So angle 1 and 5 are exterior angles, and they're on opposite sides of the transversal. So they're going to be alternate exterior angles. So we're going to put here alternate exterior angles. And feel free to go ahead and abbreviate when you can, because I know that it's a lot of writing. Okay, 6 and 7. 6 and 7 are interior angles. They're both inside of the two lines here, and they're on the same side of the transversal. So 6 and 7 would be consecutive interior angles. Alrighty. And then we have angles 2 and 4. And so angle 2 and angle 4, one is on the interior, one is on the exterior, but they're both on the same side of the transversal. And so we have that 2 is below this line, 4 is below this line. So because they're both below their respective lines, and they're both on the same side of the transversal, these would be corresponding angles. Corresponding angles. Okay, and then we have 2 and 6. And both angle 2 and 6 are interior, but they are on opposite sides of the transversal, so they would be alternate interior angles. So I hope that that has made some sense for you, and right now you need to finish off the same diagram, same directions for do-it-yourself number 2, A, B, C, and D, classifying those angle relationships. And then we're going to go to our last example. This is a very short lesson. Our last example, which is basically the same thing that we did in the previous one, but in this case you've got all kinds of lines happening. Remember that a transversal is any line that intersects two other lines at more than one point. And so what's happening in this diagram is that you have more than one transversal. For example, if I look at line J and line L, then line K is acting as a transversal because K is crossing both lines at two different points. But also if I look at line H and line K, those are two lines, and then line J is acting as a transversal because it's intersecting these two lines in two different places. And so then again you also have line L and line J, and then you have H as a transversal because H is crossing line L and line J in two different spots. So basically in this scenario, all of the lines, depending on how you look at them, can be acting as a transversal. So what they're asking us to do here is to identify the transversal that connects each pair of angles in the photo. And the reason why I put photo is because, again, I only drew the actual line segments that mattered. In the photo, you're looking at a picture in your book on page 175. But again, I think it's a picture of a railroad track. I'm not exactly sure. But this is the basic diagram minus all of the fluff of the picture. So that's why I said photo in quotes. So they want us to identify the transversal and then classify the relationship between each pair of angles. So here we go. And let's just try to be real careful here, okay? Angle 1 and angle 3. So here's angle 1 and angle 3. And so what I'm seeing right now is that we've got two lines right here. Lines L and J are the two lines that are in play, and H is the transversal. So the first thing we want to say is that the transversal is H. So I'm going to put my first part of my answer is that H is the transversal. And then I have to classify the angles. So if I kind of ignore the rest of the diagram for a second, I'm only looking at a line L and line J like this. So this is the interior, and this over here is exterior, and this is exterior. So angle 1 and angle 3 are on the exterior, and this is the transversal, and 3 and 1 are on opposite sides of the transversal. So it would be alternate exterior angles. Alternate exterior angles for part A. Okay, B says 5 and 6. So now we're looking at angles 5 and 6. So here's 5 and here's 6. And again, we're talking about the same two lines. We're talking about line J and line L. Both those angles are in between those two lines, so they're interior angles, but they're on the same side of the transversal, which in this case would be K. So our first job is to say that K is the transversal. And then what kind of angles are there? Consecutive interior. Consecutive interior angles for part B. And then we have our last one, which is angles 2 and 6. So I need to go find 2 and 6. So here's angle 2 and here's angle 6. So the two lines that are in play here are line K and line H. So the transversal that crosses both of those lines is line L. So we're going to put line L over here. And then 2 and 6. 2 is below line H. 6 is below line K. So they're in the same side of their respective lines, and they're both on the same side of the transversal L. So angle 2 and angle 6 would be corresponding angles. All right, and that's pretty much all you have to do. So now again, do-it-yourself number 3 is on the same page here, and there's 4 different scenarios, and you're using the same diagram to again identify the transversal first, and then classify the relationship of each pair of angles. Once you've completed that, you will have completed your notes for this lesson, and I will see you in class, and thank you for watching.